So, event-driven architecture, right? It's all about reacting to events as they happen rather than waiting for requests. Like how we set up listeners in our code that wait for something to occur before executing.
Yeah, it's like setting up triggers. But what if the event doesn't trigger at all?
Good point. But that's why you design your system to handle those cases gracefully. You always have default behaviors or fallbacks. Think of it as a distributed system where different components react independently to events.
That sounds complex, though. How do we ensure everything stays coordinated without tightly coupling every part together?
Well, that's where messaging comes into play. Each component can publish an event when something significant happens, and any interested parties subscribe to these events. This way, no single piece knows about the others. They just respond to the messages they receive.
I see. So it's more like a pub-sub model then?
Exactly. And it scales really well, because each component can be scaled independently based on its own load. Plus, it makes debugging easier since you can trace the flow through message logs.
What about performance? Won't this overhead of publishing and subscribing slow things down?
In some scenarios, yes. There could be overhead due to the additional layers of communication and processing. However, with proper optimization, like batching events or using efficient serialization formats, you can mitigate much of that impact.
Makes sense. But how do we know which parts of our application should use this pattern versus another one?
That depends on your specific needs and context. If you have lots of asynchronous activities happening concurrently and need loose coupling between them, event-driven is great. For more straightforward request-response models, traditional architectures might suffice better.
It seems like there's a lot to consider.
Definitely. But once you get the hang of it, it opens up new possibilities for handling complexity and scaling out systems efficiently. Just remember to keep your events simple and focused on what's truly important in your domain. Speaking of which, choosing the right messaging patterns is crucial in event-driven architecture. It's all about deciding how these events are communicated and processed.
Absolutely. There seem to be so many options like publish, subscribe, direct exchange, or even complex routing patterns. How do we decide which one to use?
Well, it depends on what you're trying to achieve. For example, if you want multiple services to react to the same event independently, publish, subscribe is perfect. Each service can listen for the event it cares about without knowing anything else.
That makes sense. But what if we need more control over who receives an event?
Then you might want to look into direct exchanges or content-based routing. Direct exchanges allow you to send messages directly to a specific queue, ensuring only certain consumers get them. Content-based routing lets you filter messages based on their content before they reach their destination.
So it's almost like setting up rules for how events are routed.
Exactly. By defining clear rules, you can ensure that each component gets exactly what it needs without unnecessary noise. This helps in maintaining clean boundaries and improving performance by avoiding irrelevant message processing.
I see. It sounds like careful planning is key here.
Definitely. You have to understand your system's requirements thoroughly and map out how different components will interact via these events. The goal is to make sure that every part of your system works harmoniously while staying loosely coupled.
It feels like there's a lot of thought that goes into making these decisions.
Yes, but it also opens up a world of flexibility and scalability that other architectures might not offer as easily. Just remember to start small and gradually build up as you understand the dynamics better. Absolutely. And speaking of maintaining consistency across a system, implementing event sourcing can be incredibly powerful.
Event sourcing? That sounds interesting. Can you explain a bit more about how that works?
Sure. With event sourcing, instead of storing the current state of an entity, you store the sequence of events that led to that state. This way, you can reconstruct the state at any point in time by replaying the events.
So it's like keeping a log of all changes rather than just the final result?
Exactly. This approach gives you a rich history of what happened, and when, which is invaluable for debugging and auditing. Plus, it ensures that your system remains consistent because every change is captured as an event.
That does sound useful. But wouldn't this make the database grow quite large over time?
It can, but there are strategies to manage that. For instance, you can periodically archive old events or implement a mechanism to prune them after they're no longer needed. Also, modern databases and storage solutions are designed to handle large volumes efficiently.
What about performance? Wouldn't replaying all those events take a lot of time?
That's true for initial loads, but once the system is running, you only need to process new events. Additionally, you can optimize by catching frequently accessed states or using indexing techniques to speed up access.
Makes sense. It seems like event sourcing could really help in maintaining consistency and providing detailed audit trails.
Definitely. Another benefit is that it simplifies handling concurrent updates and conflicts. Since each event represents a transactional change, it becomes easier to resolve conflicts or roll back changes if necessary. Absolutely. And when it comes to enhancing scalability and performance, using message brokers can make a huge difference.
Message brokers? How do they fit into the picture?
Well, message brokers act as intermediaries that manage the flow of messages between different components of your system. They help in decoupling producers from consumers, ensuring that messages are reliably delivered even under high load.
That sounds like it could really improve reliability and reduce the burden on individual components.
Exactly. By offloading message management to a broker, you can scale out your producers and consumers independently. This means you can add more nodes as needed without worrying about direct connections breaking down.
So it's like having a dedicated traffic controller for your data.
Precisely. A good example is RabbitMeQ or Apache Kafka. These tools provide robust mechanisms for managing message queues, ensuring that messages are processed in order and can be retried if necessary.
That does sound efficient. Are there any downsides to using message brokers?
There can be some overhead involved in setting up and maintaining them, especially for larger systems. But the benefits often outweigh the costs. Plus, many modern brokers come with built-in features like clustering and replication, which further enhance reliability and performance.
It seems like integrating a message broker could streamline our architecture quite a bit.
Definitely. Not only do they improve scalability and performance, but they also simplify fault tolerance. If one node fails, others can continue processing messages seamlessly. This makes your overall system much more resilient to failures.